Welcome to class 10th, acid, base and the salt. That is the part 2. So anyone, be happy. Today we expect the result of the 10th also. So be healthy, think healthy and enjoy the result. Correct? Now we will talk about the indication. The indication. First you should know what is the indicator. The indicator is a one which keep indicating. In the normal example, in the vehicle you find that when you are taking to the turn left, you will find that the left side the indicator is going to blink. Correct? But what about the acid base? Why we are putting here the indicator? Because here the purpose of indicator is to check whether it is a acid or the base. Correct? So the indicator is a one which can decide whether it is a acid or the base. The indicator we can divide into the two parts. The one indicator will be there as per the sources. Sources of indicator can be of two types. The first we will talk about the natural indicator. Natural indicator. This is the indicator which a source is present in the nature. Some kinds of the plants you will get from there. This indicator has been taken out of that. I'll give some example. For example, we are using the litmus. The litmus is to know from where it is coming. The litmus is found in the one of the plant, that is a litmus solution. That color is a purple and it is found the lichen. The lichen plant is there. From the lichen plant it has been taken, or this is a what you can say it is a dye, because it is being used to check and it has got the color is a purple. Correct? And you can find that in the group of the plant is a thallophyta. The thallophyta is a group of the plant from in which the lichen plant falls. Correct? So we will see the some of the natural indicators. The first, we will make the tabular form. How we can make it? We will make first the tabular form. The first we will write the number of the indicator. In the next we will see, we will write the color in acidic medium. The color in acidic medium. The next will be the color in we will write the alkaline the medium. Correct? I think you are clear about the alkaline and the base. All the alkaline are the bases. Correct? If the base, if it is getting dissolved into the water, we call the bases is called the alkaline. Correct? So we are taking the first. We will see is a litmus. What is the first? Is a litmus. When you put the litmus paper, the color in the acidic medium will change. The blue will change to the red. Correct? Red. Here you will find the red will change into the red color. Will change to blue. Understood? This is about the litmus. The first, the natural indicator we see litmus. The next we will see is a red cabbage juice. The second is a red cabbage. The juice. The red cabbage, the juice. Correct? Red cabbage juice. Gentlemen, you can take it, you can get this red cabbage juice out of the leaf of the red cabbage. In the market, you find that there are different colors of the cabbage. In Hindi, हम पत्ता गोभी बोलते हैं. Correct? Cabbage को क्या बोलते हैं? पत्ता गोभी. उसमें जो लाल कलर का हो उसको निचोड़ करके आप रस निकाल सकते हो. ये भी एक इंडिकेटर की तरह यूज होता है. करेक्ट? So it will convert this one into the red. Correct? Here you will find that it become the red. Whereas in alkaline it will change into the green. Correct? The third we will see. The natural indicator we are using the turmeric. टर्मेरिक को क्या बोलते हैं? टर्मेरिक को बोलते हैं हल्दी. करेक्ट? द टर्मेरिक जिसको हल्दी भी बोलते हैं. हिंदी. So turmeric when you are using, it will change into the yellow. It will change into the yellow, and if you are using with the basic, it will convert into the reddish brown. Reddish brown. Correct? Reddish brown. The fourth, the flower of the hydrogynia plants. Fourth is a flower. Flower of that is a hydra. Hydra. That is a the hydra. Rangea. Hydrogynia plant. Hydrogynia plants. Correct? The hydrogynia plants, it will color change into the blue, and this will change into the pink. Correct? These are the natural indicator which is found into the nature, and by which we can use any of the thing, whether it is a acid or the bases. Correct? That we can change it for the MCQ, for the examination point of view. You must remember it. So the first has become the natural. The second will be the opposite of the natural, that is the artificial, or you can say is a synthetic indicator. What is that? Synthetic indicator. Synthetic indicator. The synthetic indicator is what? The synthetic indicator is a one which is artificially prepared in the lab or in the factory. That is called the synthetic. So the some synthetic we can find out. Correct? For example, we are using the same. We will see here in the tabular form. We will see it is a indicator. Correct? The indicator. And next we will see the acid, or next we will see the base or alkaline, whatever say. Correct? Whatever you say. Correct? Because every alkaline is the base only. Correct? So what if we will see? We will see the phenolphthalein. The first, the spelling we will see. PHENOLPH. PHENOLPH. Correct? LEIN. Phenolphthalein. Then you put this one, it is going to change it will make it the colorless. Correct? It will become the phenolphthalein will become the colorless. Correct? When you put into the bases, in the basic, it will change into the pink color. Correct? The one more column you can make it what and how it will react when you put into the neutral solution. In the neutral solution also you can check how they behave it. Correct? So the synthetic indicator is one which can be used for the acidic, basic and the neutral, to check the neutral solution also. In the neutral, this phenolphthalein will become also the colorless. Correct? Colorless. The next we will see. The next indicator we are using, that is the methyl orange. This is methyl orange. Correct? Orange. Methyl orange. In the methyl orange, when you put it in the acidic solution, correct? Then you find that it is going to change into the, here it will change into the red. Correct? and in the basic it is going to change into the yellow, correct? And the neutral it is going to change the pink. It is a very important so far the MCQ is concerned. In the MCQ there can be the one of this one. Gentlemen, when we talk about the indicator, here we have discussed about the changing of the color, but where can be the change of the smell also, correct? We call it the odor, correct? So there can be that also. So as per also we will see what is the olfactory. As per the odor and as per the smell there is a change. So we will see it is called the olfactory indicator. That is olfactory. Spelling is OLFACTORY. Olfactory indicator. What is olfactory indicator? This is the indicator by which we can find out the acid or base when we find that the smell of the things is being changed. Those substances whose the odor changes in acidic or basic are called the olfactory. We are using the vanilla extract and the onion. So what is that? The vanilla. We are using that is a vanilla. The vanilla extract we are using extract. Or we are using the onion, correct? Onion is also there. So the vanilla extract, the onion can be used for this indicator. What does it do it? The smell of these two indicators can be detected the presence of the acid only, but not in the presence of. So this can says the smell can give you the indication of the acid only. So by this media you can check the acid only, correct? With the vanilla extract and the onion, correct? The next we will see the universal indicator. The universal indicator is a one by which we should be able to check, correct? So we'll see what is the universal indicator. The universal to judge how strong, because the indicator we know only up to here, that we can check the indicator by the indicator whether it is the acid, base or the neutral, correct? But what about what is the extent? The acid is there, whether it is a strong acid, whether it is a weak acid, whether it is a strong base or whether it is the weak base, correct? To find out that we are using the universal, the indicator is a preferred over the litmus paper, correct? To judge how strong a given acid or base is, so we are using the universal. Is a preferred over the litmus paper. This is the mixture of the several indicators. You show the different color at the different concentration of the hydrogen ion. In that universal indicator, we are bothered for the H plus ion, correct? The H plus ion, which you know that every acid, we know that every acid is having the hydrogen, correct? The hydrogen, correct? Hydrogen. And we find that when we put it into the water, the acid breakdowns, it makes the H plus, and the H plus is 1. When the H plus is more strong, much more 100% is there, we say the acid is the stronger acid. If it is slow in the breaking down of the acid, we say it is the weaker, or the 100% doesn't break into the H plus, correct? So we are making use of the hydrogen ion, correct? This is called the hydrogen ion, correct? Okay. So in this we are using this one, the hydrogen ion, as a media by which we can check. So the universal indicator is one by which we can check it up, correct? We can check whether the acid is strong or the weak, the base is strong or the weak, correct? Now the extent of the acid or the base depends upon the number of the H ion. So you know how to understand the strength of acid or the base. You understand, in the acid it is a important is a the H plus, correct? It's a the hydrogen, and in the base when you put it into the water you find that it is going to the, you have already seen the acid plus the water is going to break down, correct? So the acid will break it to the H plus, and the basic, if you take the plus the water you mix, it is going to break down into the OH minus. In the base we will say the and OH. The OH is the also the ion, the protected by the respective way. Larger the number of the ion produced by the acid is stronger. So how to find out? If you find that the H plus is more, correct? Then it is a strong. This is a strength of the acid and the base. Sentiment, you know that when you put the acid into the water or the base into the water, it is going to break down, correct? When it is going to break, the acid strength depend entirely on the number of the H plus, correct? H plus the ion, correct? That is called the hydrogen ion, correct? The hydrogen, the ion. If it is a more, if it is a more, then we will say it is a strong acid. A strong acid. If it is a less, then we will, it is a weak acid. Correct? Same thing happens with the base. In the base of the alkali, whatever you say, if the number of the ion, that is a OH ion, OH minus, if it is a more, then it is a strong base, correct? If it is a less in number, then it becomes the weak base, correct? It is a so simple. I think you understood. So H plus ion, hydrogen ion is a more and more, it is a more and more strong, correct? The strong acid, you know it, it is the HCl, hydrochloric acid, the sulfuric acid, H2SO4, then nitric acid, correct? These all are the strong acid. Rest all you will find it is a weak acid, correct? Now we'll learn about the pH scale. What is a pH scale? The pH, the scale. This is the one of the scale, the one of the measuring scale you can say has been made. On that basis you can find out the whether the solution or the any of the substance is acidic or the basic. If it is acidic, then what is the strength of the acid? What is the strength of the base? With this scale you can use. Now the come the pH. The pH is nothing, basically the as per the strength of the H plus, correct? We are going to measure it. The P is a not the Indian word. The pH, the P is a potenge. That is a potenge. The potenge, correct? P stands for the potenge, which means the power. Potent means is going to decide the power of H. So what is the meaning of that? The power of H, correct? So that way we can find out. We will see what is the pH scale is there. And this potenge word is a German word. It is a German word, correct? The potenge is a German word, which means it is a power. So we are going to calculate by the pH scale. Basically, we are going to calculate the H, correct? The how much, whether it is a H is more or the less, correct? In the pH scale, what we have in the value ranging from. So the pH scale is start from the 0 to is a 14, correct? There is one scale which keep denoting it is a 0 to 14, correct? And the 7 is a in the center. The center is a 7, correct? The center is a 7. So you find that if you calculate the H plus, H plus is a maximum here, correct? Maximum here. So this H plus is a maximum. So when you go towards left from this one, and this become, yeah, this also I will show you. So this what happens? Okay, I will keep showing this little diagram. I will show differently. So when it is a maximum, I will take it here up to here. I will go, correct? This line I am drawing, the parallel lines are there. This indicates the H plus, correct? Can you see here in the 0 side, the H plus is a maximum, and in the 14 you find that the H plus is a minimum, correct? Minimum, and H plus is at the 0 side, the H plus is the maximum, correct? You see the, so it become the acidic arrow, you can see the acidic, and here it is a the basic, understood, and this is a neutral. So when the H plus is increasing this side, when the indicator is showing, so it will start from the 0, the 1, the 2, 3, 4, the 5 and the 6, correct? It will start with the 8, 9, the 10, 11, the 12, 11, 12, 13 and the 14, correct? So we find that 7 is a neutral. Suppose you have the water, not the tap water. If you have the water, is a distilled water where the minerals are not there, it has been removed. So the distilled water is a neutral. It will have almost the 7, correct? It will have the pH level the 7. When you put the acid, if you check the acid HCl, you will find that it will be towards the 0, correct? So up to here, if it is a 7 neutral, is a 6, it become the acidic. Increasing towards the 0, it become the, so 0, 1, you can say it is a strong acid. Here you will find the acidic H plus start reducing, and when it reaches to the 14, it become the minimum, correct? Almost the nil, you can say. So that is solution, and that substance becomes the basic. So the basic will be strong when it is 14 or near to 14. If it is near to the 7, it is a weak. So this zone you can say the weak is weak base, and this zone you can say the strong. This is the strong, correct? So a strong base, correct? Here also you can say the weak acid, and this side it is a strong acid, correct? So as much as it is closer to the 0, that much effective or the strong acid is there, correct? So that is the way you can check it. So the 3 point we could learn it. What is that? The if pH is greater than 7, the solution is basic, correct? The basic. If second point, if the pH is lesser than 7, the solution is acidic, correct? Acidic. If third point, if the pH is equal to 7, then what do you say? The solution is neutral. The neutral, correct? The solution become the neutral. The pure water is having the pure water is having the 7 at the pH level, correct? Nowadays the pH meter at the electronic devices. Nowadays they have started using the electronic devices instead of the pH scale. That is called the pH meter. So nowadays the latest we use the pH meter, correct? By which we can check the pH on, correct? The importance of the pH. What are the uses? What are the importance of the pH in our life? Yes, the everything which is a liquid has got the pH level, correct? So we will see the importance of the pH level. Correct? pH, not pH. We say the pH. Importance of pH in everyday life. We will write the everyday life. Correct? What we see? The first where we find the come across the pH of the soil. The soil is around you. So the soil has got a different pH level. Suppose your soil, if you go for the testing, you will collect the few sample from your the farmhouse, different places. Correct? And if you take this soil, if you go for the testing, if you find that it is around the 7, then you say the soil is a neutral. If it is towards the that is a less than 7, the soil is a acidic. If it is more than 7, it is a basic. Sentimentally no. While selection of the fertilizer, you should use accordingly. If it is a more and more acidic or more basic, the both are harmful for the crop. Correct? So that required to be neutralized. Correct? So the soil need to be treated accordingly. Correct? So the treatment of the soil is to be given. Correct? For the good production. Now we'll see the pH in our digestive system. We know there is a HCl. The HCl is if it is coming directly in the contact of your stomach, it may harm you. So there is a formation of the mucus which the protects or make the layer in between the acid and the body parts or your stomach. Correct? So it helps to protect it, the damage of the stomach. Correct? So the what and the how much should be there. During the indigestion, the stomach produces the products the too much of the acid to correct this one, the pH level, the milk of this one. So you know that when there is a lot of formation of the acid in your stomach, you find the dhakar. When you do it, you will find the one of the Hindi word is there. When the hiccup comes और ढकार लेते हो तो मुंह में खट्टा सा आता है. Correct? Other also I will not tell you. If you go to the toilet and if you start purging, there also the acid smell will be coming. Means there is a lot of formation of the acid. What you should do it? You should use the basic thing. In the market you go on the name of the milk of magnesia. There is a lot of companies making the antacid. Correct? So this antacid you are putting into your stomach, that is able to neutralize it. So you understood how much it is essential. Next, the pH change lead to the tooth decay. The tooth decay, one of the important. I think we all are taking a lot of the chocolate. Not we. I am not taking certainly. लेकिन आप सभी बच्चे बहुत चॉकलेट खाते हो, टॉफी खाते हो और वॉश नहीं करते. मिनिमम दैट 2 times you must brush your teeth. Then only you can protect. Otherwise, I have the 32. You will find the many of the children, you count your teeth. You have lost 2 or 3 teeth. Why? Because there has been the decays. Why the decay was there? You have eaten the toffees that has gone inside and you have not taken out. Wash to karte hi nahi after taking anything. This has lead to the decay. In the decay, what is happens? The tooth enamel is there. The tooth enamel is made of the calcium phosphate and is the hardest substance in the bodies. The tooth enamel is a very strong substance. If the pH inside the mouth decreases, if the pH level of the mouth decreases, you know there is saliva, there is many things are there which is coming for the digestion. If you find there the pH level is decreasing, if it become the less than the 5.5, correct? Then what will happen? This become the acidic. When it becomes the acidic, the decay of the tooth enamels begins. Correct? So the tooth enamels, which is the stronger parts of the body, will start getting damaged. Correct? It will get the bacteria present in the mouth degrade the sugar and the leftover the food particles and perceive the acid that remains in the mouth after the eating also. So then what happens? There is a the whatever you have taken in the mouth, that will start degrading the whichever the corn or whichever the fix or the toffee, chocolate. This will start producing, converting into the acid, which remains in the after it remains in the mouth, and it will convert into the acid. The best way to prevent this is to clean the mouth after eating. To prevent the tooth decay, the toothpaste are used which neutralize the excess acid. So what you will use? So normally the toothpaste they will recommend not the normal. If the decay start, they will give the toothpaste where they can neutralize the formation of the more acid, correct, in the mouth, correct. So that is the way the dentist will advise you. Understood? Next is the self-defense by the animals and the plants through the chemicals warfare. When the insect like the honeybee ants, the bites, they inject some of the acid in the skin, causes the pain and the irritation, correct? Then you know the what type of the acid is there. If you know, just you find out what type of the acid is there. So what you will do it immediately, you should go for the soda. You find out that the basic soda you find in the kitchen. Take the basic soda, make it the paste, correct, and simply smear it. So that will neutralize the acid which has gone inside your body, correct. So it will reduce the irritation and the pain, correct. That is the way you can protect it. The pH in the plant house is also the one of the important. The sting hair of the nettle leaves. You know that nettle leaves, when you happen to go inside the jungle, inside the forest, you will not come to know, because normally we are in the habits of siding, making the jungle or the forest or anything which is coming in the bushes with the hands. When you are doing with the hands, what happens? The sting hair of the nettle leaves will go inside, correct? The inject the methanoic acid. They will put through the sting, they will put the methanoic acid. Gentlemen, the nature has given the good things. So a lot of the burning effect, pain will be there. But it is cured by the rubbing the affected area with the leaves of the dog plant. You will find that wherever this nettles are there, nettle leaves are there, by this side, the one of the plant you will find is that is called the dog plant, which often grow beside the nettle plants. It is always beside that. When you use the leaf of that one, rub it off, it is going to neutralize it. So nature also has given the neutralizing agent, correct? Next we will see the salt. Sentiment, the salt. The salt is the part of our every food. We can't avoid the salt. Salt is everywhere present. The salt are produced by the neutralization reaction. Neutralization reaction. What is the neutralization reaction? When there is a acid and plus the base is there, correct? Acid and base. Then what it will form? It will make the salt. It will form the salt and the plus the H2O. The water will be formed, correct? The reaction in which the acid and base reacts each other, form the salt and the water is formed. We call it the neutralization reaction. This is called the neutralization reaction. It is making through. It is going to make the neutral. No more acid and base. The salt and the water is no more acid or the base. So it is called the neutralization, the reaction, correct? Remember here the acid can be of the two type, correct? This can be the, suppose if you take the strong acid and the strong base, correct? A strong base, then you will find the salt will be the neutral, correct? This will be the neutral salt and the water itself is always neutral. Understood? It will be the neutral salt, correct? When you take the strong acid, correct? The acid you take the strong and plus you are taking the weak base, correct? Then it will form the acidic salt, correct? Acidic salt and plus the water. You should understand, you have taken the strong acid which will dominate over that, so the salt also will become the acid salt. If you take the strong base, correct? A strong base and the weak acid, if you are taking the weak acid, then it is going to become the basic, that will be the basic salt, and plus the water will be there, correct? The water will be there. So I think you understood. It depends upon the what type of, that is the salt which you are using, that is your sodium chloride. You are using sodium chloride, correct? The sodium chloride is a neutral salt which we are using, and this is made because of the strong acid and the strong base. The strong base is a NaOH. That is the sodium hydroxide. It is a strong base, and the other we are using the HCl, hydrochloric acid. It is a strong acid, so it is going to make the what it is the NaCl, correct? The NaCl and plus the H2O is formed, correct? So this become the neutral because of that. Understood? It is a neutral salt, so we are using it, correct? This we have understood about the how the salt is being formed, correct? The one more thing, the sources of the salt. So the common salt I explained you. The common salt. This is the common salt. The common salt I have explained, that is the sodium, the chloride, correct? The chloride is a sodium, is a formula, is a NaCl, correct? The sodium salt already I have explained you, correct? This the salt we will know something, the what is the sources of that. The common salt is formed by the combination of the, this already explained. This you should understand, the sea is a main source of the salt, correct? But it is a anything you find that there is a chloride, the Cl is there. If you find this nitrate, if you find that it is a sulfate, correct? So these all are the salt, correct? These all are the salt. So the some of the elements will be there. With that is the functional group you find like this. You should understand there are many salts are there. The sea water contains the many salt in the dissolved base. It is obtained on the large scale from the sea water. By separating other salt, it may be obtained from the it may also be okay. So this is the one source of the salt is a sea water. From there we are segregating, taking out the NaCl and supplying in the market, correct? We are making it the iodized, correct? The iodine we are mixing, correct? The iodine, this is required for to avoid the goiter disease and all, correct? So we are making in the factory, and thereafter we are supplying. So we are segregating we are taking out of the many salt solution from the this one. See, the another is a rock salt, correct? The rock salt is what? The seawater, okay, it may be also obtained from the rock salt. What is the rock salt? When you find that there is a continuous the water, seawater is coming, and if there is continuous seawater, when it comes, there is a lot of the impurities. There are the many, you will find that many insects are there. There are many different type of the salts are there. So in the rock salt, you will find that if it is continuously keep forming over each other layer, so it becomes like a rock salt. That also can be taken, and we are using the rock salt also. Deposit of the solid salt are also found in the several parts of the world. The large crystals are often the brown due to the impurities. So this all you will find that if there is a deposit of the water, seawater, that gets converted, but a lot of impurities are there. So you will find the color is normally the brown, correct? Is the question why it is brown? Because there is a lot of the impurities are there, correct? The salt which we eat, it is a white in the color because it has been purified, correct? This is called the rock salt. The bed of the rock salt were formed when the sea of the bygone ages the dried up. Rock salt is the mind like. So when the rock salt is found, it is like a rock. So we can cut it like the mining. We do it the coal and all we are taking. The same way the rock salt is being taken out of the for the use. Common salt is the important raw material for the various material of the daily use. Sodium iodide, baking soda. Okay. So one thing you understood, the common salt is a important raw material for the various material of the daily use. Like this common salt is a very important. We are common salt. We are using the uses. The one use for the food purposes, correct? For the preparation, correct? Food preparation. Am I right? The food preparation we are using it. In the factory also the different way we are using, correct? This become the raw material for the different thing, the production. That the okay, the raw material for the various material of the daily use, like preparation of the or the production, the production of the sodium hydroxide, the NaOH production also we are using. The production of the sodium hydroxide, the baking soda, correct? Baking soda, making the baking soda. The third we will see the washing soda, correct? The both are different. Please do not intermix the baking soda for the eating, washing soda for the cleaning purposes, correct? And the bleaching powder. In your syllabus, only this much is there, correct? The bleaching, the powder, correct? The powder. These are the things are there where we are making use of the common salt, correct? The one by one we will see the how we are using it, correct? The salt, I write it here, correct? SALT, very important, the salt. The salt is a very important, correct? Whether it is the preparation of the food or whether it is the production of the different materials, correct? Now the first we will see the caustic soda. The caustic soda. What is the first? Caustic soda. Caustic the soda. This is caustic soda. What we call it? The sodium hydroxide. Its name is a sodium hydroxide. Hydroxide. Sodium hydroxide formula is the NaOH. Correct? The NaOH. The how it is being made, I'll explain you. When the electricity is passed through the aqueous solution of the sodium chloride called the brine. The sodium chloride, the NaCl is called the brine also. So formula I'll write and will explain. 2 NaCl we are taking, correct? It is a sodium chloride, correct? It is a sodium chloride, correct? Sodium chloride. The sodium chloride. Sometimes we call it the sodium chloride, the brine also, correct? Brine. Let us not get confused if somebody is saying the brine. The 2 NaCl, the plus 2 H2O, that is a water. You understood? Water, it is going to convert into the 2 NaOH. 2 NaOH, correct? 2 NaOH. This is the aqueous. The aqueous is a 2 NaOH, correct? And the plus the Cl2. This is the gas, and the plus the H2. This is also a gas, correct? Cl minus, it is on the anode, hydrogen at the cathode. Okay. So when you find that you are taking, when the electric will pass through the aqueous, you are going to pass through the electric current. The current. So when you have the NaCl, when you mix with the water, it becomes the aqueous, correct? When you make the solution of the NaCl and the water, making the electric current to pass through, it will break down into the 3. 3, the product will be there. The one is a NaOH, correct? That is the caustic soda. You got it. It is a aqueous. It is dissolved in the water. The next there will be the formation of the chlorine. The chlorine is a halogen group, correct? The halogen group, all which has got the outermost orbit, the 7 as the valence electron is said the halogen, and the next is a H2. The hydrogen gas will be there. You should understand it is a gas. So the chlorine by nature is a negative. correct? So it will be going towards the anode. There will be the electrode. Through that the electricity is passing through. It will be liberated near to the this one anode, and this will go towards the cathode. Why it will go to the cathode? Because it is a positive, correct? The positive by nature, correct? Nature. Okay. The negative by the nature, correct? So it will go towards the anode and cathode. The anode and cathode, the two different gases will be liberated. So you will get the hydrogen and the chlorine gas. Anyway, so with this formula, you take, it's so easy, you can also do it. If you do it, now what you get it? You are getting three things. NaOH, that is the caustic soda you are getting, the chlorine gas you are getting, and the hydrogen gas. So three products you can get it, correct? Okay. The next one, I think you understood. The next we will see the caustic soda you could prepare it, the chlorine gas you could prepare it, and the hydrogen also gas you got it. The next we will see is a bleaching powder. What is that? Next is a the bleaching. The powder. Bleaching the powder. The bleaching powder. Sorry. The bleaching powder. The bleaching powder. So what is a bleaching powder? The bleaching powder is a calcium. The oxychloride is a calcium. Calcium oxychloride. Correct? Oxychloride. Its name is a calcium. The oxychloride. You know the calcium. The calcium, you know, it is the Ca. Oxy means oxygen, correct? The oxygen, and the chloride. The chloride is the Cl. So we will write the Cl2. So CaOCl2. This is called the calcium oxychloride. The commercial name is a bleaching powder. It is produced by the action of the chlorine on the dry slack lime. So you have the dry slack lime, correct? The slack limes, we are making the chlorine to pass on. So you take the CaOH2. This is the slack lime, correct? Slack lime is there. You are making the plus the chlorine, you are making it to pass, correct? Then the chlorine is passing on that. Then what is going to happen? It is going to make the bleaching powder. CaOCl2 is a bleaching powder, correct? Bleaching the powder. Bleaching powder is a commercial name. Chemical name is a calcium oxychloride, correct? And the formula is CaOCl2, and the H2O will be formed, correct? The H2O will be formed, correct? The water will be formed. Okay. On the standing for the longer time, it undergoes the auto-oxidation, due to which the bleaching action decreases. The usage of the bleaching powder, you know it. Where you are using the bleaching powder? It is used for the bleaching the cotton and the linen, correct? In the textile industry. So where it is used? Bleaching for bleaching purpose. The bleaching purpose कहाँ यूज करते हैं? इसको यूज करते हैं टेक्सटाइल में. टेक्सटाइल इंडस्ट्रीज. इन द टेक्सटाइल इंडस्ट्री में ब्लीचिंग करने के लिए इसको यूज करते हैं, करेक्ट? द नेक्स्ट इट इज ऑल्सो यूज फॉर द डिसइंफेक्टेंट फॉर वाटर टू मेक इट फ्री फ्रॉम द जर्म्स. ओके. as a disinfectant as a disinfectant of water, correct? अगर कहीं वाटर गंदा हो गया, उसमें जो है बहुत सारे कीड़े हो गए, हम क्या डालेंगे? we'll put the bleaching powder. You may not be knowing, earlier we were using the well, correct, for the source of the drinking water. The well, the regular, there was the bleaching powder was used because the water is accumulated and there are many leaves or many things used to automatically come inside the well. So that was leading to a lot of the bacteria and all, and the germs was being produced. To kill the germs, we were using the bleaching powder. So that is called the disinfectant of the water we are using. Water to disinfect it or make it the free from the germ. To make free from the germs, correct? Germs we are using as a disinfectant, correct? The bleaching powder we are using. The third usage of the bleaching powder is a oxidizing agent. Oxidizing agent. Oxidizing agent in many industries, correct? Many industries they are using as a oxidizing agent, correct? In the production of the many things, correct? So you understood the what is the bleaching powder, what is the chemical formula, what is the actual the commercial name, the where it is being used, and how it can be the produced, correct? So you know the everything. The now we will see the basic baking soda. Familiar about that. The baking soda, that is a sodium hydrogen carbonate, correct? It is a sodium hydrogen. So there can be the two. It can be the sodium hydrogen, sodium hydrogen, the carbonate, or it can be the carbonate, or it can be sodium bicarbonate. It can be the sodium bicarbonate, correct? Carbonate, correct? It can be the hydrogen carbonate or the sodium bicarbonate. So what will be the formula, chemical formula of that? The sodium carbonate. What is the sodium carbonate? So you will take the sodium hydrogen bicarbonate. So you take the sodium Na, hydrogen H, and carbonate. This is the CO3, correct? CO3, correct? The carbonate. Sodium hydrogen carbonate. If it is the sodium bicarbonate, we'll see the sodium, the bicarbonate. How to prepare it? The how will you prepare it? So you will take the NaCl. The first I will write the Na2CO3, that is with the sodium bicarbonate, correct? How to produce this, correct? The production of the baking soda, how to go ahead? So what we do it in the baking soda, making the baking soda, the soda, the commonly used for the kitchen, where we are using, we'll see the normal, we are very, you want to prepare the pakoda, and the pakoda you find that it should be the crunchy, something like that. It should be like a teeth, it should sound, and it should be the more pleasant, and thus you should have the more and more tasty. You are using the baking soda, correct? Chemically, it is a sodium hydroxide carbonate. It's produced by using the sodium chloride as one of the raw material, correct? We will see how to produce it. This baking soda is a NaCl. We are taking the NaCl. NaCl, the aqueous we are taking, means mixed with the water, correct? And when the NaCl is the H2O, another we are putting and making plus the CO2. The CO2, the gas, it is going, and plus the NH3. The NH3 is also gas. This is a ammonia. What do we call? The ammonia, correct? And this is the carbon dioxide, correct? Carbon dioxide gas. Then it is going to become the NH4Cl. That is a gas. We call it the ammonium chloride. This is the ammonium chloride. This ammonium chloride, and plus there will be the formation of, beside the ammonium chloride, there will be the NaHCO3. That will be the your sodium hydrogen the carbonate, correct? The carbonate will be formed, correct? This is the chemical equation of that. The following they take place when it is heated during the cooking. Okay, when this NaCO3 is being heated up, correct? When you heat it, then what it will convert? NaHCO3. Do you know this is a sodium hydrogen carbonate? When you heat, when you start heating, it is going to change into the Na2CO3, correct? That is the sodium bicarbonate, it will become, correct? And plus the H2O, and plus the CO2. Correct? H2O is a here. You get the what the H2O you are getting and plus the CO2 is a gas. Correct? You understood the gas. Sentiment, you remember. Whenever you find there is a NaHCO3, whenever you find there is a carbonate, the carbonate CO3 is there. You should understand, and the last of the reaction, the CO2 has to be formed. Correct? The carbon dioxide, because there is a CO3, it will convert into the CO2. Correct? So that also you can shoot if you don't remember the chemical reaction. Correct? So you understood the baking soda where you are using the uses, you know it. In the kitchen you are using, which is the mixer of the, okay, where you are using, you will use it. The sodium hydrogen carbonate is also as the ingredient of the antacid. Correct? So as a use as the antacid also, antacid, the antacid also it is being used. Sodium, the hydrogen chloride is also an ingredient of the, being the alkali, it is a neutralizing agent acid, and it is a, you should understand, it is a the basic in nature. So whenever you find that acidic formation is there, as an antacid you can use it. Correct? As an antacid you are using it. Correct? It is also in the soda acid for the, so it can be used for the soda acid, the fire extinguisher. In the fire extinguisher also, fire extinguisher, the fire extinguisher also you are using it. Correct? There are many uses of that. Baking soda, the baking powder you are using in the kitchen also. Sometimes you can use that for the preservative, the preservative of milk. Correct? You can use to preserve the milk for the longer period, you are using it. Correct? The milk we are mixing and we are keeping the milk for the longer period safe. Correct? The next is a, the two more are there. The next is a fourth. The fourth we will see, what is that? The fourth is a washing soda. Very important. The washing soda. Washing the soda. The washing soda. The what is the name of that? The sodium carbonate. The sodium carbonate plus the 10H2O. The sodium itself basically the sodium carbonate. Correct? Basically it is a sodium carbonate. Correct? But its formula is a little different. What is different? The Na2CO3 and the 10H2O is there. The water is there. Then it becomes the washing soda. The sodium carbonate is a white crystal solids, and the its solution is a water in the alkali in the nature. Correct? Okay, it has the property to remove the dirt and the grease from the dirt. So the washing soda we are using in the bathroom for the cleaning of the cloth and all. Correct? So the sodium carbonate can be obtained by being the by heating the baking soda. We know it. Correct? So the sodium we can get it. We know the how to get the sodium carbonate, bicarbonate. The uses of washing soda. What is the use of that? The formula is to know. The Na2CO3 is a solid. When you mix with the 10H2O, then it is going to make the Na2CO3, Na2C3 and to 10H2O. Correct? This is the formula of that. Washing the soda. It is used for the glass soap of the paper industry. The uses क्या है washing soda का? The you can use for the in the uses we will find the uses where we are using it. So it is used in glass soap on the paper, in the glass, the soap and glass soap and paper industry. The paper industry we are using. The second, what is the use of that? It is used for the manufacturing of the sodium compound like the borax. Making the borax, for making the borax, etc. Correct? So that is the sodium compound. That is a sodium compound. making the sodium compound. The third, where we can use it, that it is also remove the permanent hardness. To remove permanent hardness of the water. Correct? Water we are using. The fourth, it is used as a cleaning agent. As a cleaning agent. Cleaning agent. The cleaning agent means like a detergent. Correct? We are using like a the detergent in the houses and the laundries. Correct? We are using it. The washing, the soda. The next is a plaster of Paris. The plaster of Paris is a very important so far the medical science is concerned. The so far nowadays they are using the same thing. They are using for the decoration of the building, in the construction of the building, for the internal decoration we have started using of that. Correct? So this is the first time plaster of the Paris. Correct? So the name is given, it indicates the from where it has come to the market. It is obtained by heating the gypsum. So when you heat the gypsum, so what is that? The CaSO4. The CaSO4. Okay, first we will see the plaster of Paris. What is the commercial name? The calcium. That chemical name. That is a calcium. This is the calcium sulfate. Calcium sulfate. Correct? It is a calcium, the sulfate. Correct? The calcium sulfate. Calcium sulfate. The next is the hemihydrate. Hemihydrate. Correct? Calcium sulfate. The hemihydrate. Its formula will be like this. That is a CaSO4. The 1/2. That is a the H2O. Correct? This is the chemical formula of the plaster of the Paris. It is obtained by the heating of the gypsum. So we have the CaSO4 of the gypsum. We have the gypsum available, and when we heat up to the temperature of the 373, the Kelvin is a unit of the temperature. You must be aware of that. It is going to make the CaSO4, the half H2O, the H2O plus the half H2O. Correct? The half H2O will be there. Correct? The half H2O. So this become the plaster of the Paris. Plaster of the Paris. Correct? The plaster of the Paris. Correct? This is the way you can find out. When the gypsum is heated to the around the 400 or the 373, the dead body of the plaster, the CaSO4 is often which does not have the property of the hardening. The plaster of Paris is a white powder. Basically, it is a white powder. Correct? The white powder is there. If anything, any organ breaks, there is a bone fracture, we are using the plaster of Paris. Correct? When you want to make the roof decorative and all, we are using the plaster of Paris. Correct? So the powder or the mixing with the water is changed to the gypsum, giving the hard. So the plaster of Paris is a white powder. It is a not so hard. When it mix with the water, mixed with water. When it's mixed with the water, then the white powder, when it mixes with the water, it changes into the gypsum. Changes into gypsum. Correct? Gypsum. That become the hard. Correct? The gypsum giving a hard solid mass. Correct? What is the uses of? It is used for by the doctor for joining the fracture bones at the right position, for making the plaster support the fractured bones, and it is also for making the decorative pieces and for making the design in the ceiling. So where it is used by the doctors, to support the fracture. the fractured bones, correct? The bones we are using. And the second for decoration. Decoration. Huh? Decoration. In the decoration you can make the anything, any design you can make it, or even or making the decorative the ceiling, correct? What is the spelling of CEI? The CEILI, ceiling, correct? The decorative ceiling. When you go to the hotel or any of the places, you find that the ceiling is a very decorative, or something is hanging out of the original ceiling, complete ceiling. That is a plaster of the Paris. It is made of. The next is a the water of the crystallization. The crystal of the some compound seems to be dry by actually containing the some water molecules attached to them. This water is called the water of the crystallization. Such as salts are called the hydrated salt. Correct? The water of the crystallization in the fixed number of the water molecule present in the one formula unit of a salt. The 5 water molecules are present in the one formula unit of the copper sulfate. So that becomes the blue, the vitriol, and the other salt which possesses the water of the crystallization is the gypsum. Correct? It has the 2 water molecules as a water of the crystallization. This water is removed by heating the crystal of the hydrated. So the little level, the 2 sentences only you remember. What is the crystal water of crystallization? The next is the water of crystallization. The water of the crystallization. The crystallization. The water of the crystallization. The water of the crystallization means how it is the crystal of the some components seems to dry, but actually the contains some water molecules attached to them. This water is called the water of the crystallization. Such salts are called the hydrated salt. The salt, which is a solid, it is called the hydrated salt. This is the hydrated salt is there, correct? Salt is there. Water of the crystallization, the fixed number of the water molecule. When we talk about the water of crystallization, it is the fixed amount or fixed number of the water molecules present in the one formula unit of the salt. The 5 water molecules are there present in the one formula unit of the copper, the sulfate. In the copper sulfate, when we find the copper sulfate is there. Copper, the sulfate. In the copper sulfate, what we find? That is a blue. The blue, we call it the blue, the vitriol there. In that you will find the CuSO4 is there and the 5S2 is there. That is the crystal, correct? The 5 is there, correct? The 5 unit is there. So there we have which possesses the water of the crystallization, correct? So we will see the other salt which possesses the water crystal. The water crystal other we find that is a gypsum. That is a gypsum. The gypsum is also one where the water crystal, the water in the form of the solid is found. This is the gypsum is a CaSO4 and the 2S2O is there, correct? 2S2O. Here the 2, the crystal, the particles are being used along with that. It has the 2 water molecules. So we are using the 2 molecules. That is 2 molecules of the water, correct? The 2 molecules of the water of crystallization is being used, correct? The crystallization is being used, correct? So here we are using the 5 molecule of the water of the crystallization, correct? This water is removed by this water. This crystallization of the water can be removed. The water content can be removed by heating, correct? The heating is the one way by which you can remove it, correct? So gentlemen, this topic acid, base and the salt is over. Thank you very much. Please do subscribe, pass the comment and share to your friends. Thanks a lot. Jai Hind.